practice problem kinematics from Rick and Morty. I made this up from Rick and Morty, the show, but it could be anything really. So Jerry is on a ladder and he falls. And let's say that he starts from a height of 2 meters and he hits the ground. Pretend like Rick didn't save him. How fast would he be going when he hit the ground, and how long would it take? And the time was so we could say how long Rick would have to react. Okay, so this is a kinematic equation, a kinematics problem. We know that his acceleration is g. Right, so the acceleration is going to be actually negative g. Now, what else do we know? Well, we can pick down here this as y equals 0. So his final position is y equals 0. His initial position is going to be the height h. Now from that, is there any equation that has the final velocity? Yes. There's 2 ways to do this. I'm going to do it 2 ways. The first way is the logical way to say, okay, I'm going to take the kinematic equations, and here's one of them. V squared is V0 squared minus 2gy minus y0. So this is an equation that does not have time in it. If I'm looking for the final velocity, it has the final velocity. It has the initial velocity, which I also know. He starts from rest. And so I'm looking for the final velocity. I know the value 2. I know g. I know the final position is 0. The initial position is h. So I can just solve for everything right here, and we're going to do that. So v squared is 0 squared minus 2g, and this is going to be the final position is 0 minus the initial position of h. And you'll see here that I have a negative and a negative, so this is going to be a positive, which is a good thing, because if I take the square root of a negative number, I'd be in trouble. So I get v is the square root of 2gh. Also, let's just check the units. This is meters per second squared times meters is going to give this meters squared per second squared. And then when I take the square root, I get meters per second, which is what I want. Let's put in our values. Square root of 2, 9.8, 2, and let's calculate this with our calculator. Turn it on. Clear. 2, 9.8, 2. I could have done the 2 twice. And then take the square root. And I get 6.26. That wasn't too bad, huh? Now the second question about the time, how long does this take? Actually, we have more than one way to answer this question too. Let's do the way that I think makes the most sense, and to use the equation y is y0 plus v0 t minus 1/2 gt squared. So that's my favorite kinematic equation. Let's just put in everything we know. I know my final y is 0, my initial is h, my initial velocity is 0, so that term's gone, minus 1/2 gt squared. I want to solve for time, so let's add that to both sides. I get 1/2 gt squared equals h. I'm going to multiply by 2 and divide by g, and I get t squared is 2h over g. So t, I'll put it up here, t, see if you run out of room, is the square root of 2h over g. Let's just check, right? H is in units of meters divided by meters per second squared. So this whole thing is going to be seconds squared when I take the square root. I get seconds. So that's going to work. So t is the square root of 2 times 2 divided by 9.8. Calculator. On. Drop. So it's going to be 2 times 2 is 4. I'm just going to say 4. 4, 9.8 divided by square root. I get 0.638. Let's say 0.64. Okay. Now, let's do the first problem a different way. So imagine that I didn't care about order and I said, well, I want to find out how fast he's going, so I'm going to find the time first. And I did this. I could do that, okay? Now I could use that time and another kinematic equation. I'm going to erase this whole thing. Once I find that time, which I just did, I could say v v0 minus gt. So I know the time, I know g, I know the initial velocity. So this gives me v equals negative 9.8 times 0.64. And let's put that in our calculator. 9.8, enter, 0.64 times. 6.27, negative 6.27 meters per second, which is about what we got before, but not quite the same because I did round and I didn't have the square root and I have a negative, right? I actually had a negative before because I took the square root and you get plus or minus the velocity, so that's fine. Now, what if I wanted to find the time a different way? I could have used the final velocity I calculated here to calculate the time. So there's many paths that you could take to get to those two answers, and you can choose your own adventure.